Hello, everybody. My name is Bartosz. I'm working at Stack HPC as a cloud engineer. I'm also a OpenStack core reviewer, and we have also Michal.
Yeah, hello, my name is Michal Nasiadka. You can call me Michael if that's easier. Yeah, so I'm a senior technical lead at Stack HPC, long-time core reviewer and project team lead for like, I don't know, 6 or 8 cycles. Yeah, so let's go.
Let's start a bit about our company. It's almost 10 years old, Stack HPC. We are based in Bristol, United Kingdom. Most of the people are there, except a couple of locations in France and Poland, where we are from. And we are, as the naming says, founded on high-performance computing expertise, focusing on delivering that to customers with SDN, software-defined networking, and mostly around research institutes like universities, but not only. So we are addressing that with our open source heart, I would say. We are an Open Infra Silver member, and by recent metrics across several releases, we are second or third, depends on the release. By personal day effort metrics, contributor to OpenStack. Therefore, I think that's somehow significant for that small company, I would say. We have also other open source projects, like Azimuth, for example, and everything is open source, even documentation. Okay, today we are going to talk about OVN in OpenStack and some challenges around that. Let's start from reminding ourselves how does it work from the internal point of view. So we've got our cloud, I hope that's visible somehow. This lovely schematic, which I adore, is from OVN documentation, but I very like that. So we have on the top cloud managed service, in our case is Neutron, and its OVN driver. It can be different, like I think somebody mentioned kubeOVN, for instance. So it's our networking configuration in OpenStack being translated to northbound database, OVN northbound database by a CMS, by the driver, in case ML2 OVN. In northbound database, we are storing logical network configuration, router, network subnets, that we all know from OpenStack. Then it's being translated into lower level flows by NordD component to the southbound database. NordD is, like I mentioned, translating that from high level desired state configuration into low level flows in southbound database. In this case, a southbound database is, in my opinion at least, heart of that, where every hypervisor is connecting to. A small remark, it can be a different way, it can be done by southbound relay as well, which is a recent improvement in that, especially in big scale if you have like over several hundred hypervisors, then you would need that relay for sure. So Soundbound database is comprised of those flows and physical binding for each hypervisor. Then OVN controller component. By the way, northbound and southbound databases are clustered components utilizing Raft algorithm. So it's highly reliable. I haven't seen a crash, to be honest, on that front, at least yet. So we are on OVN controller, which communicates with southbound databases or relays and translating flows from southbound database to actual open flow flows to configure OVS instances running on each hypervisor. So in our case, Neutron 8 CMS communicates with northbound database, and like I mentioned, the ML2 OVN driver in Neutron communicates with northbound database. External ports are somewhat which interest us the most in this presentation, because they are a representation within the OVN for external entities like bare metals, needs which are needed for OpenStack Ironic project here, and SR-IOV network interfaces of virtual machines. So those external ports are logical ports within the OVN, and they are providing OVN services which are needed for those hosts, like DHCP, DNS, and also IPv6 router advertisements. In OVN, we are configuring those external ports on northbound database like every other logical component. Important to notice is those ports are being managed by HA chassis groups between the chassis, which is in OVN nomenclature, the dimension of the hosts that will be configured. That's a network node, that is. And this will be important in the issues part of this presentation, or rather challenge, I would say. HA chassis group is important. That would be, it needs to be connecting outside, of course. So L2 connectivity is needed, and in the OVN configuration is a local net port, which basically means a VLAN. Okay. Very good. So I tried to replicate a bit the OVN documentation in terms of styling, at least. Sorry. No, that's not good. That's not good. Okay. Anyway, so I would like to go through the logical flow of this setup, how from the OVN perspective, how it should be configured. Is it visible? Probably. So on the top we have our bare metal or SR-IOV NIC virtual machine. It's obviously connected to the physical network directly. Then we have HA chassis group on our network nodes, which is in highly available communication between those several network nodes, for example. And then we have local net port, which is a VLAN, like we mentioned before, connected as within the logical switch and logical switch port type external. And that's important because it's actually associated with a HA chassis group. And then we are going to the Node-bound database, and which is then serving our OVN services that we would like to have. Like mentioned, this is important bit. I would like to be mentioned as well that this is, for example, SR-IOV, well, the primer, like I mentioned before, but it's enabling high performances to bypassing the kernel network stack, and our bare metal ports managed by Ironic. And important bit is that Neutron external ports are special types. So to be able to utilize that, you need to specify the VNIC type within the Neutron configuration. Right, and this is also important that it don't need to be configured directly in OVS, of course, like all setup of OVN. Okay.
Okay, my turn. Yeah, so basically, Neutron has a mechanism that schedules external ports onto gateway chassis. So there are different scheduler plugins that can be used. The default is the least loaded scheduler, which will do a priority list of your all network nodes at maximum 5, I think. And it takes the least loaded gateways in the front of that list, which ensures efficient scheduling in terms of load distribution. Then we also have the HA chassis group that was mentioned in previous slides. So it's a concept introduced in 2019 to manage multiple HA chassis for those services that the external port needs, like DHCP and others, and DNS, for example. And it ensures that the external ports are bound to the master chassis based on priority. So, yes. And of course, if master chassis handles the port and it fails, then the backup will serve those additional services like DHCP and DNS. Yeah, so challenges. So external ports and router gateway ports may be bound to different chassis. So you end up with having DHCP and DNS. Well, DNS not really working because OVN will forward the DNS query to some upstream DNS server, and if there's no router on the same chassis, it's not going to do it, right? Yeah, so basically if you have different priorities on the HA chassis group and different priorities on the logical router port of your router, you end up with lack of routing. Yeah. So there's also another problem, but it has been already handled by Neutron since Yoga. So in the past, there was like one HA chassis group, which caused MAC address issues. But now we have one HA chassis group per logical switch, which ensures no MAC flapping between physical switches, which they don't really like. Yes, so currently redundancy is managed separately by Neutron for gateway ports and external ports. And it leads to lack of routing, right? Yeah, so there's a history behind it. So initially there was an option in logical router port entity that was called redirect chassis, and that was the only option. It was then deprecated when gateway chassis table was introduced. And then in 2019, OVN developers introduced HA chassis group for handling external ports. Yes, so we had 3 different options that could be like defined for routing, because if you have, if your logical router port does not have gateway chassis entries, OVN will use HA chassis group for routing, right? Yeah, and in version 2012, so it was December 2020, redirect chassis has been removed and docs have been updated with some recommendations how to use gateway chassis and or HA chassis group. So basically, if you set only HA chassis group, routing will work, but Neutron currently is setting both gateway chassis and HA chassis group with different priorities. Yes, so possible solution that we're working on. So aligns sharing strategies for both external and router gateway ports, so these are consistent. And use HA chassis groups consistently across all port types, but sort of. So initially there was a plan of a new scheduler for OVN that will align gateway chassis and HA chassis group priorities, but since the latter can be used instead of setting the former, so we only set HA chassis group and we don't need to set gateway chassis, it's a matter of rewriting the logic. But there's a feature in Neutron that is called enable chassis as export host, where you can choose that the HA chassis are different than the gateway chassis. It seems that there are use cases for it, which I don't know which ones, but there are, right? Yes. So basically, yes, we're rewriting the logic to take into consideration if enable chassis as export hosts are enabled in your environment, then we will do what Neutron is doing today. And if not, we would just set only HA chassis group, and then the L3 routing will work properly. Yeah. And that's it.
Do you want a microphone?
Document as in, you're asking if it only needs documenting how it works today?
Is it a documentation issue, or is it actually like these things can be scheduled separately today?
So basically, those can be scheduled separately today, but you won't have the L3 routing capability for your bare metals, for example, right? Yeah, with introducing the enable chassis as export host, there's some part of documentation in Neutron which says that it's like a useful for some use cases, right? Which I don't know which are those use cases. It would be good to document them. Yes, but basically, I don't think it's expected for most people to boot a bare metal and they get the HCP, but they don't get L3 routing outside of their network, right? Yeah.
I think the export host feature was also for some totally separated environments
Yes.
with different communication needs or setup,
Without the routing.
and or without the routing, yes. Thank you. Anybody? Question?